Hi, my name's Terrence, I'm a Linux engineer, and I've been involved in systems for about 15 years. And as long as I can remember, everybody's been absolutely obsessed about managing servers rather than services. I'm not really sure why that was, because at the end of the day, we don't really care about hosts. We really care about the services that run on top of them. And even today's tools, they still observe this bias. If we continue to implement services on a piecemeal basis, then if something goes bang, we have to move something somewhere, it necessarily implies we have to put it back to a correct state in a piecemeal basis sort of way. Anybody who's done that, not nice. So I have a different approach. My key thing I'm trying to manage is the service, not the hosts. The demo you're going to watch, not terribly long, it will show you how to restore a bind service, and that's comprised of a bind master and 3 slaves, each of which has dual interfaces to support an internal and external view. One of the interfaces is tunneled. That's to get around Google Compute Engine's static op table. Because when I build something, I want it to work anywhere. AWS, Google, work anywhere. And somebody of limited skills, matter of fact, don't have to have any Linux skills, an iPad can follow simple instructions, can restore this service, up to and including all the complex networking that is required to get bind 9 with views working correctly. Anyway, if this sounds interesting and you would like to turn your servers into an automated service process, I'd love to hear from you. If you're a professional and you have any comments on what you see, always keen to listen to my peers. So sit back, hope you enjoy it, and would certainly love to hear your thoughts. Thank you. Because current system automation tools work on a host and not a service basis, this means that hosts cannot be built interactively and cannot configure each other, and it also makes it likely that editing in multiple host configurations will result in errors and inconsistencies. By creating hosts on a service basis, we can gain the following benefits. Portability. We can migrate services between different clouds and or network segments. We can gain consistency, working with one configuration file versus editing many. We can create complex networking, which would have otherwise had to have been done by hand. Maintainability, no chain of dependencies, iPad, Bash, SSH, Git, done. Manageability, no Linux skills to deploy, restore, migrate services. Just the ability to follow simple instructions. In order to show how the results were achieved, I've maintained continuity. Please feel free to skip ahead to sections which are of more interest. Although this diagram looks big and scary, anybody who's configured bind for views will tell you it's far from that. If you just go into your iPad and you Git client, in this case working copy, and update some host names, subnet mask, IPs for the internal and external interfaces in the 2 files specified, commit, push them to the Bitbucket repo, and then run some commands on the bind master, after which you clone that repo, join all the slaves to the master, running ssh-passwordless-config.sh. Then finally, the bind9-install-script.sh forces down all the configuration on everything, and it all rises up correct, and bind9 just works. Although it's possible to create hosts in AWS's CLI and completely automate the process, my goal was to demonstrate that somebody with a basic skill set could produce something as complex as a bind9 installation using views. So I've used the web interface. If you already know how to create hosts in AWS, whether through a web browser, CLI, please skip ahead. For those of you who are interested, please stick with me. Our bind master is going to be 10.0.0.54. Our bind slave 1 is going to be 10.0.0.55. Our bind slave 2 is going to be 10.0.0.56. And our bind slave 3 is going to be 10.0.0.57. All hosts read the same configuration script. However, they test that script against their own host name, and if it matches, they apply that configuration. This next section is related to changing the actual host name of the hosts. Nothing fancy or exciting about any of this. It is just a necessity to ensure that they are configured correctly. If you know how to change a host name, please skip ahead. If you don't, keep watching. Next, we're going to configure the host, which will become the bind master for Git connectivity. Since we're working on a service-based deployment versus a host-based deployment, we will not get involved in individual configuration. We're going to pull down all the code from the Git repository into the bind master, which will configure itself, and then it will force down these same scripts in turn to each slave configuring them. Now that we've created a sensible place to download the code from the Git repository, we have to configure the access to that Bitbucket repository. So we're going to create a set of keys, after which we will copy the public key, and then we'll open a web browser and paste that into the Bitbucket account so we can reach out and grab the code from the Bitbucket repository. Before we actually download anything from the Git repo, we need to go into working copy, which is a Git client for the iPad, and we need to update the IPs, the subnet mask, and the hostname variables in the bind9 install script. We can also update the tsig and RNDC secrets as they've been turned into alias variables. Now, for the master internal interface and all the internal interfaces, we're going to use the AWS assigned DHCP addresses. The external interfaces, they're arbitrary. These will be created when we configure the hosts, and they hang actually off of ETH0 as tunneled interfaces. I've assigned them to one dot, same number as the internal interface, for the sake of organization. We'll now check to make sure our changes are correct. Now we'll go and update ssh-passwordless-config.ssh, and here we are just going to plug in the ETH0 internal interfaces. This script is merely concerned with setting up the connectivity that the bind master can force down all the software and install it on the slaves. Once again, we'll check the correctness of our edits, and if we're happy with that, we're going to go ahead and commit our changes. Some sort of a sensible note about what we've done. And then finally, we're going to push our changes from the iPad up to the Bitbucket repo. Before we leave working copy, we're going to copy ssh-passwordless-config.sh. This is one of the few things that really can't be automated. The file needs to be installed manually on each host. Once it is, then everything else is an automated process. Now that we've updated our configuration files with the AWS environment information, the master is now going to clone the repo from Bitbucket. Before starting the configuration, I'd just like to establish that these hosts are in fact clean. They do not have any prior SSH tunneled interfaces configured on them, nor is bind configured on them. Please feel free to skip ahead if you accept that the boxes are clean and you don't need to see the tests. We're now going to configure the master's SSH access to the slaves, and we're going to do this by creating empty files called ssh-passwordless-config.sh and pasting what we copied in working copy into those files and saving them. A bit about the operation of ssh-passwordless-config.sh. All hosts will start off with the same key to establish initial connectivity, then create new keys, exchange them, and all will delete the shared key, after which the SSH service will be restarted using unique keys. For purposes of demo continuity, the configuration of slaves 2 and 3 with ssh-passwordless-config.sh is also shown. You don't really need to look at it. Feel free to skip ahead. We don't need to create ssh-passwordless-config.sh and paste it on the master, because when the master downloaded all the config files from the Git repo, it had the most current version of this file as well. When the script is run on the master, it will hang until the script is successfully completed on all the slaves and the new keys have been generated and exchanged, and only after SSH can be restarted will the script complete. This is where things start to get interesting. We're going to configure a bind master and 3 slaves in under 4 minutes. Now that we've got the SSH connectivity between the master and the slaves, we can run the bind install script. After the master is done configuring itself, it will go ahead and force down a tarball onto each slave in turn, unpack the tarball, run the scripts locally, and then reboot the slave, move on to the next one, and then finally it'll reboot itself. Notice that the feedback is colorized. The status message is colorized, and you get the host name, script section, so if you do any modifications, you can see how far things got and where it broke if you want to modify something. The master ties up its own scripts, and now that's what the slaves are going to get. We're moving on to slave 2 now. Tarball's been unpacked. Now it's looking for any debris from prior installs, and it'll remove any scripts or packages from prior installation attempts to make sure we start with a clean slate. Now it's creating the SSH networking, and it's beginning the name.conf configuration. It's configuring the zone transfers now in the RNDC, setting permissions, restarting networking, restarting bind. Now it reboots slave 2, and then it moves on to slave 3, and we start again. Right, after all our hosts have rebooted, first thing we'll do is we'll just verify that all the networking came up correctly. The first thing we're concerned about is the tunneled interfaces which serve the external view. There we go. We can see the tunneled interfaces seem to have come up correctly. Let's make sure that they're contactable across the network. 1.55 is, which is first slave. 1.56, the second slave, is also contactable. Answers. 1.57 is also responding to pings. So they're up and they're contactable. Now, let's check the status of bind running on the master. All looks good so far. It's up and no errors. Now, let's run some lookups against the slaves on their local interfaces, the internal view. 0.55 returns a local address. 0.56 returns a local address. 0.57 returns a local address. And this is what we'd expect to see from an internal view. Now, let's do lookups from the slaves to the master on its internal views interface. There we go. We've got a local address back from the first slave. Do another lookup from slave number 2 to the master on its internal view interface. And as we'd expect, we see a local address, and we will repeat the test for doing another lookup against the slave on the internal view for our domain name, and it passes the test. Right, we've tested the internal view to ensure that it's serving the correct information with local IP addresses. Now we're going to query the external view, which carries a subset of information and should only display public IPs. And as we can see, 91.85121.20.21, those are public IPs. So that would appear to be serving from the correct pot of information, and it responds, more importantly. Now we do slave 2. Yep, we're still seeing public IPs, so serving from the correct pot of information on the external view. And we're going to go to our last slave. And this answers correctly, and we also see public IPs returned in lieu of local ones. So the external views are contactable and they're returning correct information. To ensure our bind servers aren't open to abuse, we're going to test them to make sure they don't do recursive lookups. So we're going to check a domain for which we're not authoritative on slave 3. Great, refused, perfect, what we'd expect. Do it again for slave 2 on its public IP address. We get refused for that one too, very good. We do it for the final slave. We get refused. Right, we're on the bind master now, and we're going to test the failsafe networking by killing the tunnels to the slaves, to their external interfaces. So we're going to do a PS, find the process ID of each slave's tunnel, then we're going to kill it. After we kill it, we're going to start a ping, and we'll let the ping run, and the expected behavior is at some point the tunnel will rise up again and the ping will respond. Success. 1.55 is up and responding to pings now. The tunnel's been restored. We'll do this again for our next one. Okay, we just killed 56. As you can see in the listing, the tunnel's gone. We'll start our ping. Success. 1.56 is up and responding now. Do the final one. 57. See, 57 is no longer up. Start our ping. Success. 1.57 is now contactable and its tunnel has been restored. Next, we're going to test fail-safe services. And that's to say that if we shut down named, would it start automatically on its own? We're going to start testing on the master first by killing named. Okay, named is stopped is the current status. Let's wait a little bit before checking the status. There we go. Named restored itself and it's up and running correctly. Now, we're going to break named on the slaves, but before we do, let's just establish that named is in fact running correctly on our slaves before we do any testing. Okay, named is up and it's returning correct results on the slaves. So we're going to go to our first slave after establishing its name service is working correctly, and we're going to kill that. Okay, the current status is named is stopped. So wait a little bit. We'll check our status. There we go. Name automatically restored itself. Let's move on to the next slave. Named is up and running. Shut it down. Okay, current status is named is stopped. Oh, too soon. Give it another try, and there we go. It has automatically restored itself. Let's go to the last slave. Named is stopped is the current status. Try again. And there we go. Named is automatically restored itself. So fail-safe services are successful.